Alexa, play Hamilton. Good morning. And okay, thank you, Alexa. Yay, Hamilton. Alexa, volume down a half. Hopefully, this is working. So, good morning, everyone. It is now almost 10 o'clock, our usual. And if no one comes, what I'll make sure is that I go over the answers. Good morning, Sophia. How are you? I'm glad to see you're safe. Yay, Sophia. Anyway, so I'm going to go over the questions in the end of the unit part 2 review. And I want to also announce that I'm going to try something new. I'm going to try Zoom. And what I want to do is on Good Morning, Brady and Lulu. What I'd like to do is I would like to, on Sunday, have a Zoom where we play Kahoot. But the requirement is everybody must pop popcorn because, hey, if you're going to do a Sunday for 20 minutes or so of playing Kahoot, popcorn and Kahoot. What a way to go. Okay, good morning, Isaiah. So, what we're going to do is, first of all, are there any questions about yesterday's in, uh, review, end of unit review, part 1? I mean, if you saw the YouTube live recorded video, I went through every single question. So, if if there are any questions or you want me to go over any particular points, this will be. Can we ask questions about review 2? Most definitely. Let me get that document up. I will put the key to 2 in Google Classroom tomorrow morning. I know it's the weekend, but hey, I know some of you check and do homework over the weekend, but I'll have it up so you can do self-correcting. All right. If you know the date and the number of hours of sunlight an area receives, can you approximately? Yes, you can. Knowing that at the equator, it's going to be 12 hours every single day throughout the year, that you can actually tell based on a comparison with other locations that where it is approximately, what latitude it is approximately. If it's winter time in your area and you move further away from the equator, the days will be significantly shorter until you get to the North Pole or the South Pole, depending on what your winter is. And that's when you'll see that, oh, yeah, 24 hours of night. Whereas if it's summertime and you're in a particular area that is experiencing summer, the days will get longer as you move further away from the equator until you get to where you have 24 hours of daylight. Okay, so let me get the questions ready for you. I'm going to go. We are now looking at planetary unit test review part 2. What direction does the Earth rotate? Everybody should know that one. What direction does the Earth rotate, you guys? What direction? You can tell me. Good morning, George. Good morning, Hannah. What direction does the Earth rotate? Does anybody remember? Let's just say it's not going to be in this direction. It's going to be counterclockwise. Great, Grady. The direction that which the oh my God, the Earth rotates. All right. How long does a full rotation take? Well, tell me, how long does a rotation take? What do we call one rotation of the Earth on its axis? What do we call that, you guys? 24 hours, and it's also called a, and thank you, Sophie, for your response. And it's also called a, and here's Rocky, who has been crying. It's called a day. That's right. So when any planet rotates, that's their day. When it orbits, that is its year. Its orbital period is its year. Revolve is 365 days. Rotate, for the Earth, by the way, rotate is 24 hours. Okay? So now let's look at question 2. And I'm going to go to my sheet. And it says revolve a year, and we've done 11 and 12 already. Yay! So, what is the relationship between the orbital radius and the revolution? So, here we're talking about orbital radius, the distance from the sun, have to do with the amount of time its orbital period or revolution around, what does the orbital radius have to do or with the amount of time it takes for a planet to move around the sun? So what happens to that? And I'm waiting for responses. Hi, everybody, and so good to see Grady and Brady and Sophia, Isaiah, Gregory, Hannah. Welcome, everyone. I hope Louisa, Lulu. I love it. I love your formal names and your nicknames. So, what does the orbital radius have to do with the length of time it takes for a planet to go around the sun? Think about it. Hi, Sarah. Its mass? No, it doesn't affect the mass. The orbital radius actually is talking about the distance from the sun or the distance an object is from it. Good morning, Kaya. Um, okay, I'll just go ahead and give it to you. Sorry, no one's answering. Wah, wah, wah. Anyway, the orbital radius, the further away the planet is from the sun, the longer the orbit. Yes! You did it before I said it. That is awesome. All right, yes, that is true. The further away an object is from the sun, the longer it's going to take to go around the sun. Remember, science is logical, it's not illogical. Wouldn't that make sense? That it's going to take a long time? Good morning, everyone. So let's look at the next question. All right, here I go, looking at the next question. Why do the seasons change as Earth orbits the sun? So, as the Earth orbits the sun, what happens to the tilt? As the Earth orbits the sun, what happens to the tilt? Okay, Noah, good morning, Noah. Make sure you guys do those. I've been checking your end of unit parts 1 and 2. I'm trying to do it so you'll get feedback right away. And also, I put in, just as an aside, I put in the key, and I will put the key to today's end of unit part 2 in the classroom tomorrow. Is it tilts toward the sun and away from the sun? You are correct. Distance away from the sun has really very little effect on the weather. It's the tilt. It's either tilted towards, away, or the tilt in the spring and fall is not in play. The rays are more direct, but the seasons are changing. Um, when it orbits Gregory's, and thank you, Sophia, for your answer. And Gregory, your response is because when it orbits the northern and southern poles, change side. When it faces towards or away from the sun, yeah, the tilt does change. Remember, the Earth doesn't go like this. Instead, as it moves around, it changes the tilt. So here it is right here, where it's tilted away, and it continues to orbit around, and then when it gets right here, it tilts towards without the Earth wobbling back and forth, which is kind of funny to think about us feeling a wobble and we're on the Earth. So let's look at the next question. I'm on now, question 15. If the Earth were not tilted, would seasons change? Would daylight hours vary? Would solar angle vary? Okay, so this is a little bit more spring and summer. I mean, excuse me, did I say spring and summer? I should have said spring and fall. There, I corrected myself. Think about that. The weather between that you see at spring and fall. Oh no, I see that my connection is failing. Oh no, oh no. Can you guys still see me? Hi, Tara. Oh no, darn. Ah, I lost connection for a little bit. So sorry. I got a little notice from YouTube. But let's look at this question that we were talking about spring and summer. Yay, we can hear me. Yay, thank you so much. I tell you guys, I miss the interaction one on one and one on 3000. I miss that. But again, this is a plug for Kahoot and Popcorn Sunday night study for the upcoming assessment on Monday, Tuesday, how long it takes you. Thank you, Alex. I guess You guys are just like awesome. I brag about you to my mom all the time. She can't believe how awesome you guys are. And she taught in California for years. But here goes. Think about it. If you notice that the weather between spring and fall is very, very similar. Okay? So imagine that would be in where we are, our weather all the time if there was no tilt. Okay. And the further you get away from the equator, you're going to see that the weather will be cooler and cooler and cooler. Whereas the equator, they never really get much difference in their weather because they always get straight on rays. Okay. And the length of day, think about our length of day during spring and fall. That would probably be our length of day all the time. But as you go further north of us, the length of day would decrease. I know, spring and fall weather all the time. No snow, or occasionally we get snow in the spring, but that's like weird. And occasionally we get snow in the fall, but that's closer to winter. Anyway, but think about that. That as you get further away from the equator, if we had no tilt, the length of day not would decrease as you get closer to the poles. Okay? And especially at the poles, can you imagine to always be in twilight all the time? So you'd have to look at what their spring and weather, their spring and fall daylight hours are, and that would be what it would be permanently at the poles. So yeah, our temperature, the same thing, because you're far away from, you're not getting the tilt. So you're not getting that warming. All right, so let's go to the next question. And the solar angle would not vary that much. If you know the date and the number of hours of sunlight an area receives, can you tell approximately how far it is away from the equator? Most definitely. I think, Isaiah, that was your leading question for today. Most definitely, especially when you know that you can look at it like we have that question where you look at it at different times throughout the year and comparing the cities, you can tell what's north because when it's winter, they're going to have short days. When it's summer, they're going to have long days. If you're at the poles during the winter, you're going to have no daylight. During the summer, if you're at the poles, uh, yeah, if you're at the North Pole during the summer or the South Pole during the summer, it's 24 hours of daylight. In fact, they show I read an article years and years ago where Alaskan children get so confused about it's light outside, like more light outside than it is right now with the cloudy day. So imagine, your whole body clock gets thrown off. Uh, no, the test quiz isn't today, Kaya. The assessment, which will not count against you, is just data. So I want you to make sure your data is good for me. Is on Monday and Tuesday. You take it for 20 minutes. After 20 minutes, save for later. Take it Tuesday for 20 minutes. It's only going to be part one. Only, you know, multiple choice, matching, that kind of thing. Okay. Um, I'm going to actually try Zoom for Kahoot on Sunday. And what's nice about that is remember popcorn. So I have the Kahoot app on my cell phone so that I can actually use my cell phone to respond because I'll show the choices on your screen and you can use your cell phone to literally make your responses. Okay. So yay, Zoom. And we're going to have Kahooted and Popcorn Sunday at 7 p.m. review. And that way I get to see you, you get to see me, and we'll eat popcorn as we play. All right. All right. So, anyway, let me go to the next question. Number 17. So, we've just finished 16. Number 17. Look at this data table. Oh, see, I don't have the data table I can show you, but there are some questions about Uranus. And here goes. How many times more massive than Earth is Uranus? What is Uranus's gravitational force compared to Earth? And what factor other than mass must affect a planet's force of gravity? All right, so coming back to you guys. All right, so here we go, you guys. Uranus is 15 times more massive than Earth. Okay, imagine 15 times more massive. Distance would be, but we're going to get to that. And it's only 0.89 of Earth's gravity. So if you weighed 100 pounds on Earth, you would weigh 89 pounds on Uranus. Crazy because it's 15 times more massive. So there's got to be something else that affects its gravitational force because it is more massive than much more massive, and yet it has less gravity. What could that be? Hmm. Distance is one thing. That would be its volume and size is just so much larger than Earth that if you put all the mass, even though it's 0.89 mass more massive than Earth, it's not its density is not as great as Earth's. So it is a gas giant. Yes. So in Uranus's case, what really affects um, its gravity is its size. Okay, that's the other factor. Because it is so much larger than Earth, um, its size would affect its gravity. So it's got and that, but in most cases, it's distance away from an object. So yeah, its moons are way far away. In fact, when you get further out to the gas giants, the moons are so spread out. Now, for just in case, I will I will actually first of all, I'm looking at all the responses. Yeah, I can't wait to do Kahoot with you guys on Sunday. Remember, popcorn and Kahoot Sunday. All right. All right. And it's a review, so I'm having my popcorn, you pop your corn or your smart food, whatever you use for popcorn. Hey, bring it. Bring it on. Anyway, I just can't wait to see all your faces instead of just reading your responses. The moons of all of the outer planets, by the way, Isaiah, are super far apart. Okay, they are super far apart. And remember, what happens if you have a really thick atmosphere? What's the temperature of your planet going to be like? You have like Venus. What's it going to be like? Exactly. Well, it has 15 times more mass, but if you look at its size, that mass is spread out over such a huge size that it does affect its gravity. Great. Yeah, it is correct, Tara. If you have um, a, a super dense atmosphere, you will not have as thick, you will not have as great as the temperature range. It's going to be hotter. It's going to be way hot. Like Venus, there is no temperature range. It's just straight 460 degrees Celsius all day, every day. Okay. Wow, 462. Whew, can you imagine the air conditioning bills on that planet? So, what happens if you have no atmosphere? What will the temperature range be like? And I've got one more question, and I've got 50, 40 something seconds to say it, like 30 seconds to say it in. So, I'll give you the answer. If you have no atmosphere, you're going to have a wide temperature range. And finally, what can you say? Oh, shut. Um, I had one more. Oh, yeah. What's the best method? What's the first method they used to detect an exoplanet? We haven't talked about that in a bit. What's the first method they used to detect exoplanets? Wobble, that is correct. And transit is probably the most accurate method where they look for the blinking of the star. Well, you guys, I can't believe how fast 20 minutes go. Unbelievable. And you know what? I can't wait to see you guys tomorrow. I wish I knew where I was staring because I think I'm staring at you, but I could be staring at there. I could be staring here. Hey, wherever I'm staring, I've never been on TV. Well, yeah, well, I have been on TV. But anyway, bye, you guys. It's been a pleasure. You guys are awesome. Can't wait for our Kahoot and Popcorn Sunday night as a review. And you know what? It's been a pleasure. You guys, It's been a pleasure. Goodbye.